Good afternoon, viewers, and welcome to Kiimanetwork Network. I'm Samson M. Braga, and today we'll be going through the introduction of limit. So now, there was a question in the comment section that talks about the application. Where can limit be applied? Where is limit applicable? So now, we use limit in so many areas of fields. We can use limit to measure the strength of a magnetic field. We can use limit to measure the strength of an electric field. And we can also use limit to gather pieces of relevant information in a complex number. So now thank you for the question, and let us go through what we're here for today. The introduction of limit. So when we talk about limit, what is limit? Limit. What is limit? So we say limits are values in which a function approaches, right? Are values in which a function approaches. So now, limits can be categorized into various sections. We got the right hand limit, and we also got the left hand limit. So we got the right hand limit, and we also get the left L-E-F-T limit. So these are one-sided limits. So once a limit is said to be a right-handed limit, it means that the values in which a limit is approaching from the right-hand side, meaning the value is positive. When the limit is considered as a left-handed limit, then meaning the value in which the limit is approaching at the left-hand side, which we call the negative part. So we can say, for example, of a right-handed and a left-handed limit would be the limit as A approaches, or we can say as A approaches P, f of x. Here's a right-handed limit. Why? Because the limit is approaching of positive values, approaching of value from the right-hand side. So now there's a right-hand limit. So we can say there's a right-hand limit. So now let's talk about the left-hand limit. The limit as A approaches P from the negative side, f of x. So there's a left-hand limit. So when we talk about a right-handed limit and a left-handed limit, it simply means where the limit is approaching at. So now, let us talk about the various rules of limit. There are so many rules of limit. We got the addition rules. We got the multiplication rule. We got the subtraction rule. We got the division rule. And we also got the constant multiple rule. So now, let's drive through those rules here. Let's talk about the sum. The sum rule. When we talk about the sum rule, we can say the limit as s approaches A of f of x plus g of x. So if we get something like this, how can the sum rule be applied? It simply means we should share this limit into two. But mind you, there's an operator between them which will have the positive. So there's a sum rule. So in opening the limit out here, the limit as s approaches A to be f of x plus the limit as s approaches A of g of x. So there is a sum rule. So now let's move to the subtraction rule. So we say subtraction. Subtraction rule. So it's similar, the limit as s approaches A, f of x minus g of x. So notice that addition and multiplication, they work hands in hands, right? So now, we apply the same rules, right? There is a subtraction rule, so we just need to open up the limit, right? Each one of them should carry their own bono. So we get the limit as s approaches A, f of x minus the limit as s approaches A, g of x. That's the subtraction rule. Let's move to the multiplication rule. Say multiplication. the limit as x approaches a, f of x times g of x. So what it says, open a limit or as well, the same concept, the limit as x approaches a, f of x times the limit as x approaches a, g of x. So we know the multiplication. Let's move to the division rule. Division. So we get a limit as x approaches a of f of x divided by g of x. Right? So we are opening all the same way. The limit as x approaches a, f of x divided by the limit as x approaches a, g of x. So we just dealt with the addition rule, or which we call the sum rule, the subtraction rule, the multiplication rule, the division rule. What's about the constant multiple rule? What if we have a constant value, wherein we solve a limit, we have a constant value. There's a rule that is applied to it, which we call the constant multiple rule. So we say the constant multiple rule. We say the limit as x approaches a for f of x. There's a constant value, right? 4 is a constant. So how can this rule be applied? So we say equals, we factor out the 4 across the limit. Factor out the 4 across the limit, so we get 4, the limit as x approaches a of f of x. So these are the rules that we are going to be working with. We'll be working with the sum, the subtraction, the sum which we call the addition rule, the subtraction rule, the multiplication rule, the division rule, and the constant multiple rule. So ladies and gentlemen, please like, share, and subscribe. We are going to solve many problems using these rules. So please like, share, and subscribe. Thank you very much.